Alrighty, this is going on page 95 when we're done. All right. This is sinusoidal function context and data modeling. So just like all the other functions that we've done, after we talked about the functions and the pure math part of it, then we looked at it in context and, in a real world type of situation. That's what we're doing with these. So we've already seen that a sinusoidal function can be written as this, or in a similar form with cosine, right? It's either sine or cosine. To construct a model, we'll need to connect information that is given verbally, graphically, numerically, and algebraically to the properties of a sinusoidal function graph. Okay, we're just kind of taking all the pieces and putting them together. Okay, so the first thing we're going to look at is graphically. So here's a graph, and this says, let f be a sinusoidal function. So it's good that it tells us that. I mean, it looks like it, but it needs to tell us that so that we know for sure. The graph is on the xy plane. All that means is it's graphed like you expect it to be graphed, and I want the period of f. So even though it doesn't ask me for the midline, I'm going to go draw in that midline. Okay. Then, does it matter where I start, what x value I start on to figure out my period? No. So whether it's sine or cosine, it doesn't matter at all. If you can start at 0, I would suggest you start at 0 because it makes it the easiest, right? So if I start here, that draws one cycle, okay? Yes, that's okay. Which means your period is 2, right? And no matter where I start, I still get 2. It's just easier to count that way. Sometimes your x values have pi's on them, sometimes they don't. So just pay attention to that as well. All right, any questions on that one? We've been doing period for a while. I think you're good on that. Okay, so example 2. We're going to let g be a sinusoidal function, and it gives me this equation. The graph of g of x is drawn or sketched for us. Which of the following could represent the constant c? So again, I'm going to put in my midline here. And I'm going to remember that cosine looks like this, right? And then I'm going to figure out which one is c. C is my horizontal shift. It's shifting me left or right. So for cosine, we start on the y-axis before we shift left and right, and we're up from the midline, whatever a is. So I'm starting right here. Everybody okay with where I'm starting? I'm starting here. 0 would mean that I don't shift either way. So that's not going to be my answer, right? It's not even touching my graph. Now, if this was a negative cosine, then would it be okay? Yes, because then it would have a reflection, but that's not what it is. All right, so then pi fourths. If this is how it's written, that means this is x plus pi fourths. Which direction am I going? Left. So if I start here and go left pi fourths, not even touching my graph, not my answer, right? So I'm going to start here. This would be x plus pi halves, which means I'm going to the left. So I start here, go to the left pi halves. I'm touching my graph, bless you. That's something, but that's not everything, right? So, bless you. Once I'm here and I'm touching the graph, if I then start to sketch it, it should look like this, and it does, so I think I like C. Good. Then let's go ahead and look at D as well. D would be x plus pi, which means I'm going to the left. So I start here, I go to the left pi, not even touching my graph, clearly not D. Okay. What questions do you have? Because I know the first couple of times we did a graph like this with the C, it was like confusion city. But you understand how to start now and where to go with that? Okay. All right, good deal. Let's look at example 4. Clock is mounted on a wall, and the point P is located in the tip of the minute hand of the clock. Okay, so here's my clock. I'm not going to put the minute hand on there yet because I don't know if I need to. The function h represents the height of P from the ground at time t, and then this is my equation. The xy plane, I've got these 2 points. H of 0 is at 70, H of 30 is at 52. That represents a maximum value and a minimum value, respectively, on the graph of H. Okay, so this is my clock, or this is my motor, or this is my whatever that is spinning, right? My merry-go-round. You know, they're all going to be some sort of circle that's going around here. If this is given, this says this is a maximum and a minimum value, respectively. So the maximum distance from the ground is going to be right here. So this point is 0.70. This point right here, hey, thank you. Got them all done? Yeah. Appreciate you. We've got, this would be at 30.52, right? Maximum, minimum. 70 feet off the ground, absolutely, because the ground's down here somewhere, and so, yeah, you've got that going on there. Now, these are where these things are happening, but remember our graph, we're not really worried about this being on the XY plane. We're looking at something more like this, right, which might have a shift or something in it. So I'm going to take this information, and I'm going to do a little sketch with that information, like we have on a couple of the others, where I have a Y value at 70 and a Y value at 52, and I'm totally not to scale, and that's totally fine. And then I have an X value of 30 and 1 at 0. So then my points, I have a point at 0.70, and I have a point at 30.52. Okay. So if it says sine, so sine would have to be shifted to make that happen, but that's fine. But I'm taking that information and putting it on my graph. We all good so far? And we are being asked for the values of A and D. Of those two, I think that the easiest one to find first is D, and even if we don't, just like on everything else, we want to draw in our midline. Okay, midline is right there. How can I figure out, using that 70 and 52, what that Y value for the midline is? That's what I would do. I would add them together and divide by 2. I'm going to show you a different way that's come up a few times today. But remember, I don't know if I've said this before, but if you have a piece of string and you want to find the middle, you take the 2 ends and you put them together and you cut it in half. So if I'm trying to find this middle right here, I'm going to do 70 plus 52 and then divide by 2. So that gives me 122 over 2, which is 61. So this right here is at 61, which means D equals 61. So then the next thing I need is A. These are the two things that they asked me for. What does A represent in the graph? What's it called? Amplitude. So my amplitude is the distance from the midline to a maximum or the midline to a minimum. So what is that distance? 9. It's either 70 minus 61 or 61 minus 52, and I get 9. Okay. Well, in this case, it's not going to be net. Yeah, it's positive. So this only we don't have any information to think that it would be negative. Okay, we good on that? Okay. So then here's another way. Here's the other thing that has come up today. When I've said, how could we find D? How can I find that Y value of 61? So the first thing that was the most, confident thing that people agreed with was that we should subtract these two. Well, we can do that, and if we subtract those two, we get 18, right? As long as you know that D does not equal 18, you're okay. Then you half it, then you get the 9 here and the 9 here, and that's fine. So you actually end up with this first, and then once you have the 9, you can subtract and use the 61. Either way works. Both, they get you the same answer. Whatever makes the most sense to you is totally fine. Okay? All of it? Yeah, that's what I mean. All of it. So I subtract these two and I get 18 is the difference there. If I cut that in half, I get that the amplitude is 9. If I know that the amplitude is 9, then I can just do 70 minus 9. It gives me 61. So whichever way, that's to find the midline, and we found the amplitude along the way. We found it before we even, but it's, it's the same either way. Whatever makes the most sense. Yeah, you good? Okay. All right, so flip this over. Now we're doing example 3. Okay. So a yo-yo that is attached to a 30-inch long string is rotated at a constant rate. The figure provides a representation of the yo-yo in the xy plane with the direction of the rotation indicated. That's what those little arrows are there. So at time t equals 0, the yo-yo begins to rotate. The yo-yo is at the start position in the figure. Okay, so here's the yo-yo. This is when it starts to rotate. When time is 0, then the y value is negative 30. Okay, we okay with that? All right, so then at time t equals 5, the yo-yo has completed 20 rotations, and it's in the same position. So it's back here. So we went around the circle 20 times, right, in 5 seconds. And so we're right here. Well, this point isn't going to have the exact same ordered pair. But the ordered pair 5, 20 doesn't make any sense, or 5, negative 30 doesn't make any sense, because this is like, remember how I told you the graph of the unit circle is different than the graphs of the sine and cosine that we are doing, right? And so this is going to be 0, negative 30. This and then this would also be 5, negative 30, because in 5 seconds I've, right there, over and over again, I just keep rotating. That's why we need a graph that looks more like this, that just keeps on going this way, and then I can have 0, 5, and whatever. Okay, you with me on that? So another ordered pair that I have is 5, negative 30, because it tells me I'm at the same spot. Okay, so don't worry about trying to put it on that circle and make sense of it. Remember that the circle just keeps drawing on top of itself, where the sine and cosine functions that we're drawing, they continue to stretch out and can go on forever. Okay, and that's kind of how we unrolled that unit circle. Okay, so we want, let's see, let me continue reading here. Blah, blah, blah. A sinusoidal function is used to model the x-coordinate of the position of the yo-yo function of time in t seconds. Which of the following functions is an appropriate model? All right, so when I look at these, they all have an amplitude of 30, which makes sense, right? Which kind of makes sense from there. Makes sense to have an amplitude of 30. And then sine, they're all sine, so really all I have to worry about is the part that's in here, right? The b value is what's different. What is related to the b value in your functions? The period. Good. The period. All right, so we got to figure out the period. So it says at time 5 seconds, we have completed 20 rotations. So I know in 5 seconds, I've done 20 rotations. I want to know in 1 second, oh no, I'm sorry, no I don't. I want to know how many seconds, I told mess that up. 5 seconds, 20 rotations, how many seconds for 1 rotation? You've been doing proportions forever, right? You can set up a little ratio in proportion. So now we can cross multiply and get 20x equals 5 times 1, which is 5. So x is equal to 5 over 20, which really we're right back where we started from, but I didn't want you to think it was like a magic proportion. Really, it just said x equals 5 over 20. Then this reduces to 1/4. Okay. Does that mean my answer is A? No. What does 1/4 represent? The period. Okay. Is the period, does P itself belong in there? No. I use that to find B. What goes in the numerator here? 2 pi. 2 pi divided by the period, which is 1/4. What does that give me? Which is 8 pi. And your B is 8 pi. That's this right here, which is letter D. Okay. What questions you got? We good? Because when it's 2 pi divided by 1/4, you keep change flip. I'm going to multiply 2 pi by 4 over 1. You have to multiply by the reciprocal. Alrighty. Next one. The average monthly temperature in degrees Fahrenheit for a town in central Indiana can be modeled by this function. from 1 to 12 months based on the model. Which of the following is true? Okay, so it's talking about the maximum and minimum temperatures. So I'm going to sketch something out so I can wrap my mind around how we figure all that stuff out. So I have here's something that I know from here. I know that this is helpful. What does that represent? The midline. So I'm going to sketch in the midline. Boop, boop, boop. And this is at 61.2. Okay. If I want to know what the maximum value is, I would take 61.2 and add what to it? The amplitude, yes, which is 25.7. And then before I even try to add a decimal, let's see if I even need to. Look at the A choice. The maximum average monthly temperature is 61.2 degrees. Is that true? No. So I don't really even care what it is when you actually add them together. I know it's not 61.2. The next time it talks about maximum, it's asking you where it occurs. We're going to come back to that. Okay? Then it talks about minimum. So minimum, and again, totally not to scale, but that's okay. I would take 61.2 and do what? Minus 25.7, because that's the amplitude, right? Now, that one, I think we're going to need to actually subtract and have a little bit of a decimal review here. 61.2, if I'm going to subtract another decimal, I have to line my decimals up. Don't be making up math. Then you just bring the decimal straight down, right? Okay, 2 minus 7, can't do that, so I have to borrow. That gives me 5 here. 0 minus 5, I have to borrow again. It gives me 5. And I get 35.5. So looks like C is a pretty good answer, right? Your test-taking strategies, you really should always check all of them. And we are going to talk about the other two because it's a completely different way of thinking. And so if we just say, ooh, the answer is C and move on, and we never talk about that, then you don't know how to look at those. So let's get more of our graph on here. I know that this means I move in which direction? To the right. And this is sine, so I know that sine looks like this, right? So I'm going to move to the right 4. We'll say that this is 4. And then I'm going to have a cycle of sine that looks something like that. We okay with that? So I'm going from 4 to I don't know where. That would be the period right there. Is that something I can figure out? Yes. I can, for the period, I'm going to take 2 pi and divide it by the b value, which is pi 6. And what does that give me? Close. It's just 12 because the pi's cancel out. Okay, so if the period's 12, this is 4, this is 16. I'm going to circle them because I feel like I'm getting lost in all the mess here. What would this number right here be? Oh, well, really right here. Right here. What's that number? What's halfway between 4 and 16? 10. All right, so I have one cycle that goes from 4 to 16. Now, what we know about sinusoidal graphs is that they actually continue on in either direction. And they go on into infinity and negative infinity. We don't always use all the entire graph. It actually tells me right here that we're only going from 1 to 12. But even though we're technically only going from 1 to 12, we can look at what's going on with the rest of it. And by that I mean this. Whatever is happening at m equals 1, since your period is 12, it's going to happen again at 13. And then it's going to happen again at 25, and so forth and so on. Does that make sense to you? Okay, just like whatever happens at 4 happens again at 16, right? Because we just start over. So I can really look at 13. 13 is between 10 and 16, right? Is that a maximum? No. So then that's a no. The minimum at 7, okay, 7 is between 4 and 10, right? Do you have a minimum between 4 and 10? No. So then it can't be D. You see how that works? Now, if we really wanted to look at 1, we can do that as well. But to me, that's a little bit easier, just understanding how the period works. But if we wanted to look at 1, here's something else we know. The distance here is 6. The distance here is 6, right? So every time I hit a 0 on the midline, it's 6 more. So that means this is going to come down, and I'm going to get this piece basically. Starting here, I'm going to get that from here to here, and it's going to take 6, which ends me over here. And you can tell it's really not to scale. I've got that right there going on, right? Because you can tell everything is spaced. And then you can see that 1 is in here, and there's no way their maximum is at 1 because the graph dips down like that. Okay, so you can look at it either way. What questions do you have? Anything? Okay. So now is when we need our calculator. So this says the function n gives the number of nighttime hours on the first day of the given month from 1 to 12. The table gives the values of n selected at values of t, a sinusoidal regression with 16 iterations used to model the data. What is the maximum number of nighttime hours predicted by the sinusoidal function model? So we're going to go to our calculator, and where do we go to lists and spreadsheets? So for lists and spreadsheets, go ahead and get that stuff typed in. All right, so once I have it all in, do the same steps I have for regression before. Let's hit the menu. Then what do we push? Statistics 4 and then 1. Is this a linear regression? No. Hopefully we're past the point where some of you think everything's a linear regression. But nothing that I can see makes sense either. But if we arrow down, do you find something that makes sense? Oops. Yep. See, sinusoidal regression right there. And then it's the same stuff you've been doing before. Choose your X, choose your Y, enter. Okay. And it gives you A, B, C, and D. That's one reason why we're using those letters and not the H and K that you might have seen before, because that's what the calculator uses. All right, so let's think about, so now it gave us all this. That's great. Well, we're not going to write any of it yet. We'll figure out what's going to help us with this, right? So let's come back over here. And the first thing I would always put in here is my midline. So you're looking at your calculator, and I can't see mine anymore. It's 8 something, right? 8.5. Okay, we'll just put 8.215. Okay, do what? So that's D, right? That's what this is. Now we want the maximum number. So I want the maximum here. If I want this number, I need to add this to it. What does this in general represent? What is this part called? Amplitude. This is A, your amplitude. On the calculator, what does it say A is? Okay, 3.117, we'll put that. So to find the maximum value here, I'm going to take D and add A to it. That's also what we did right here, right? We took D, we added the amplitude. We took D, we subtracted the amplitude for the minimum. So we're doing the same thing here. And so this is going to give me 8.215 plus 3.117. And that gives me about 11.3 into the nearest hour. That would be 11. No. We're going to do this a second way. Okay, because that's one way to do it. But you need to know the other way to do it, because that's something that we need to be able to do. So we're going to go back to our calculator. And, oh, I hit the wrong thing. Hopefully it's still recording. We're going to go back to our calculator. And we want the maximum. So we can do that from a graph. So let's add a graph. Control, doc, add a graph. Add a graph. Okay. When I do that, it starts me at F2. Why is that? Because I have my graph in F1 already, right? I can't see it, but when I arrow up, it's there. So if I arrow up to it and then hit enter, it'll show up. Now don't mess with your window because we can't see the maximum, right? That's okay. We know what the graph looks like. So isn't your maximum somewhere in here between these two minimums, right? So that's all I really need to know at this point. Menu, we will analyze the graph. We want the maximum, and then just move this over so it's close to the minimum. I mean, it doesn't have to be super close, but so you obviously aren't, try close to your maximum. Hit enter, move over, or tap it, whatever, however you want to do it. And then it fixes your graph and gives you the maximum. But make sure you pull off the y value and not the x value. I don't know if that's even an option on the answer choices, but you got to make sure you know which one you're looking at there. Okay, so I think you had an issue on Saturday we fixed, right? So one thing we didn't fix. So does anybody else not have a bunch of decimal places? Okay, you? Okay. So so we changed I don't know why you have to change it in two places, but you do. So if you're here and you don't have a bunch of decimal places, hit menu and 9 for settings. Do float 6. Also make sure these two things are checked. You don't have to worry about the rest of it. Make sure you hit make default if you have that option, and then you should be good. Yeah, exactly. So Alfin, did we already change your other part? You did? Okay. It's just that you have to change it in two places, and we didn't do that the other day. Okay, we good then? Beautiful. Okay. So are we all good on that? And either one, like I said, either one works. One's not even an answer choice, so it'd be kind of hard to do it wrong from there, but you get about 11. Okay? What questions do you have? You don't need those settings for the SAT, but because you have to clear the calculator, it clears out all the settings and everything as well. But they don't matter for that type of stuff. Yes. Yes. Alrighty.